Cool. Hey, everybody. Thanks for being here. I'm TC. Steve, I think we've known each other quite a few years now. And I think in Steve's second incarnation of Fortify Media, we're working together on an interesting project. I'd let Steve fill in on some of the stuff we're doing.
Oh yeah, Steve Cronin. I'm the CEO of Fortify Media, and we have been working with StorageDNA to integrate the intelligence into the digital archive. My journey started about 25 years ago as the IT and digital asset manager on the Matrix sequels, and this was really the culmination of 25 years of that learning. Of basically being handed a printout from Matrix 1 of being like, here's a list of all the files from the previous movie, go tell us what you want. But of course, we didn't have a visual index of anything. So to go and request something to be pulled from a tape in a cave and hope it retained its value was a guess. And we ended up just recreating everything. And, this was in 2001. And sadly, it's a very common story still today, in that we tend to have this wall between the production and the studio. We give them this kind of freedom to create, but in that creative freedom is chaos when it comes to the operational organization of a lot of these files. We've seen visual effects, introduce some consistency through naming conventions and these other patterns. And so what we've really done here is to take a different approach than what I did in my previous company, which was the digital asset management sort of system. And with the DAM, we tried to build systems that engage creatives and get as close to that point of creation as possible to try and enrich that content as much as we can. And this is kind of the inverse of that. It's kind of letting the production or the project do its thing.
So let the chaos ensue, and just to build a layer of organization on top of that, right? So I think this has been a goal to do that. So
And of course, what happens typically at the end of a show is this huge problem that keeps accumulating, which is you get this dump of a drive or a tape, whatever it may be, and the curation of that becomes quite difficult because you're handing it off to people who have very little context. They don't know the nuances necessarily of each scene or each story or each set. And so it ends up things get reshot, things get rebuilt. I was the backbone of Marvel Studios, and they literally recreated their logo multiple times over because they just couldn't find it. So sad story, but here we are.
yeah, and I think one of the big things that we're running into even beyond your studio project is any post production department has the same issue, right? Which is tons and tons of content across your NASs, your SANs, LTO. How do you locate stuff and repurpose it, right? Quickly. And I think one of the things we found is can the index that you build across all of the storage essentially become your single source of truth, right? Let things exist where they are in their dams and their MAMs and their NASs, but can we pull it all together as one intelligent layer, right? So that's sort of what we've attempted to do here. So.
And when we talk about an index, essentially we've created a database of every single file that exists almost across the whole studio. That's our end goal. And not only just indexing the file path, but being able to index its checksum or embedded metadata. And that gives us this deduplication map across the whole studio, which comes with a phenomenal kind of guide, because when it comes to curating, 20 years of chaos, the first pass you really want to do is figure out, how much of this is duplication, how much do I need to focus on cleaning up. So the intelligence that just comes by purely creating that initial database gives us the foundations to build so much automation on top of.
Yep. And I think breaking down the individual pieces. Steve, you want to take this because you're the brains behind this one.
Yeah,
So.
it really got broken up into a set of microservices. So, of course, the index, being the DNA fabric, which we connected to on-prem storage, and we have huge amounts of cloud data in Box and Dropbox and S3. We have LTO tapes that also could be indexed in the future. But building that layer then allowed us to build multiple services that could take that database and then build metadata intelligence and file conversion on top of that. So to move from a pipeline of just this big search index, the first thing we wanted to do is visualize it. So as you're browsing a file on S3 or browsing a file on-prem, we built these on the fly thumbnailers. So literally from your on-prem storage, you're looking at an image, a video, whatever, it's generating those thumbnails on the fly to give you a visual of everything that exists, no matter where it is in the world. So we can have a Pixit in the UK and a Synology on-prem in Sydney and whatever it may be. The first step was that first problem I had 25 years ago with how do I visualize it and confirm this is what I want? And then the next step is, okay, once I've visually
And I
confirmed.
want to actually add to this bit that this is before the orchestration has even kicked off, right? This is to let the users just get an idea of what this data is that's sitting across the world before you decide what you want to do with it, which is one of the things that I found that was really neat is the engine that Steve's built, you can be browsing content and in real time it generates your thumbnails for you, which kind of blew me away when you kind of showed that piece to us, right? And I think it's super critical because you need a view into what you have before you decide what you want to do with it.
So yeah, first service, super high speed thumbnail generator of basically any file type as you're browsing on the fly. Then the second part became, okay, how do we streamline the ingestion of going from massive amounts of data into an intelligent taxonomy? So we integrated the other data sources to help us inform us of what these files were. So that was FileMaker, ShotGrid, Synchronize, Sync on Set, even breaking down the script. That's going to give us the list of characters, the list of vehicles, all sorts of ways to translate a just a folder name or a sub element in a file name and turn it into a key value pair that was useful for the faceted search and sort of translating just the dumb data into more intelligent data. And so by um, doing this, we normalized around the MovieLabs 2030 ontology, OMC, and there's different layers of AI we've had throughout this whole process. And one of the first ones is normalizing the data. So I've got my ShotGrid structure over here, and I've got my OMC data structure over here. Now, one click, boom, maps all the fields together. So the way that we're using AI throughout this process isn't just the traditional, we're going to visually analyze your image and tell you it's got a dog and a cat. And that's really great for stock footage scenarios. This is a supplement to that, which is taking all the story data and how do we make it more useful to the creatives on the shows? How do we describe that it's not just an image, but it's concepts, it's a storyboard, it's a previs, it's getting a little bit more nuanced as to how do we actually describe this. So we take all that metadata and aggregate it into this sort of metadata service so that as we're pushing data through the pipeline, we can translate these folder paths and file names into searchable metadata. Then we're taking things like 3D models and we do smart camera intelligence to figure out how do we create a turntable automatically. We take all the frames like EXRs and convert them to QuickTimes. So it's filling the gap within there is a DAM that we're publishing into, but the DAM doesn't support all these file formats. It can't present the 3D models, or it can't, necessarily, you don't want to ingest the millions of frames that you might have in your larger database, the larger index. So it's building this kind of layer in between of how do we translate from the 20 years of archive into the subset of the valuable assets that you want to extract from that archive, put them into DAM, which is going to have all your additional watermarking and search and all the rest of it. And that is all orchestrated either manually through selecting a batch of folders or automated through leveraging some of the triggers that StorageDNA has, like a rule that might say, if I see the word final in a file or a folder, automatically push that into the DAM. So we can have these kind of automated triggers that can help ensure that the most valuable content is at least getting snapshotted into the DAM, allowing you to do other, sort of workflows with.
Yep. So yeah, one of the things that definitely jumped out is the non-traditional use of where you hear AI is getting applied, right? I mean, there's this idea that it's all for, you know, metadata enrichment, but I think what we did on this project is really look at LLMs on how it can be used to deal with messy metadata, right? I mean, it's something that gets talked about very little, but it's how do you take years and years of legacy metadata with keys and values that have been misspelled and spelled differently across different databases? How do you normalize it? How do you make it uniform? How do you vectorize it? How do you embed it? I mean, these are challenges that you just don't hear being spoken about. But I think it's a far more sort of realistic use of AI than a lot of the stuff we hear all over the show floor. So, yeah, this is kind of, I think, a bit more detail on the end-to-end pipelines. If you want to,
Yeah, so in this example, it might be you've got a set of EXRs that just drop in, and you see that you want to push them in. It's going to first put it through that make a call to the ingestion pipeline, detect, do I need to do a conversion? It's going to spin up a GPU instance, process that extremely quickly. It's going to look at those file names and folder paths, and if it sees underscore ILM underscore, it's going to know that that was the vendor. If it sees a particular file naming convention, it knows the sequence underscore shot. It's it's sort of taking all of that so that when it goes into the DAM, we can actually go into a final archive taxonomy directly from the source. Yeah.
yeah. Well, one of the things that I also want to highlight is most of the backend infrastructure used on this project is scalable, spinned up containers on demand, right? So the engine is not just uh, handling the actual ingestion, but it's also handling, do I need to spin up another container? Do I need to spin up another transcoder? All dynamically in AWS, right? Which, if any of you are familiar with the server and the on-prem hardware issues everyone's facing, is an entirely virtual pipeline that scales up and down on demand. So
Yeah,
other
a lot of hard
interesting piece of
lessons,
this.
a lot of hard lessons in the damn world of orchestrating in AWS and the costs of all that. So a lot of that went into how efficient the transcoders and those efficiencies are.
Also, a quick results slide. Steve, you want to highlight?
Sure. Yeah. As far as manual tagging, like I said, we've taken 20 years of data, and millions of files got ingested in the first week, all in a unified, organized taxonomy. Huge range of format support. Every file type. All the 3D model formats, all huge range of video codecs. The goal is how do we move from these armies of people that it used to require to try and extract the value from your archive and automate that as much as we can with AI as the assistant to help guide you through this aggregation. And as we all know with AI now, it's all about context. So what we're building is a huge context library to help inform this data as it moves through the pipeline.
Well, one of the things that's interesting is this little last line of the blurb, right? That even though we've used a lot of AI technology, right, more than a lot of other projects, but you won't see that word splattered around this presentation, and it's because it's a tool, right? It's an engine that's going to make certain things more efficient, right? It's not an end all, and that's how we used LLMs and meta extraction in this platform. One of the interesting things was that one of the most efficient pieces of the pipeline was the one that Steve wrote, which was about dynamic thumbnail generation, right? There's no concept of AI in there, but it's one of the pieces that lets you discover your content sitting remote, sitting across the world very, very quickly. I mean, that is one of the key operational efficiencies of this project, right? It has nothing to do with AI, right? So we just wanted to highlight that piece as well. So
Yeah. One of my favorite features we built was using this duplication logic of using checksums across the whole studio. There's now a policy where you can filter and say, not only hide the files that I just chose to ingest, but hide all of its duplicates. So as I'm chipping it away at a bucket, if I choose this as the file I want to ingest, then all those other duplicates get hidden from me. And so I can truly just like chip away at this kind of mountain and know that I've got everything in there. I'm not having to deal with all the chaos. So that was super powerful.
yeah, so I mean, what's next? What are some of your thoughts on
Well,
where we're going with the project, where studio should be going?
and just to kind of wrap up, the value of what we're doing here is we're taking what traditionally becomes a problem of we have all this rich media, but we don't have the processes that are efficient enough to go and extract those assets. So it becomes easier to recreate. And so what this is now doing is empowering the licensing machines, the marketing machines, the reuse. whether it be a LiDAR scan of a fighter jet, or like in Green Lantern, the production designer was the art director on the first film. And as they're talking about spinning up the TV show, they're like, not only do I want, that data, but I know there's all these characters that we built that we never used. And now I'm moving from a film to TV. I've got to build a universe. So it's not just those final assets, it's everything. It's everything that was ever created has value. And you just never know where that's going to come from. But you need to build a system to allow people to go and find it and decide, is it there? Do we need to shoot another panning shot of New York again, or scan another jet? So that's where the value that we've hugely seen. And then where it's going now is because we've aggregated all this data, you start getting other opportunities on top of that. So now you start building a RAG chat on top of all the shot grid data. And now I can query what's every shot that's due from ILM next week, or how much do we spend with, Weta last year? So that's the interesting side effect of this data aggregation to inform the file pipeline, is you get this other intelligence.
Yeah, I mean, I think I think one of the key aspects or takeaways for me was that you're never going to be able to fully control how every department in an organization functions. They're going to make their choices on how they create their data, how they name their data, what kind of dam they pick, what kind of a database they're putting their content into, from spreadsheets to, a review and approval tool. But all of these different silos contain metadata that contains value, right? And instead of trying to put everything into one bucket, we're saying, hey, let things grow as they are. Let's aggregate it all. Let's normalize it all. Let's use AI. Let's use LLMs in this pipeline aggregation process, and then drive value, right? And I think we were onto something here. So.
I come from 25 years of working in DAM, and I think a lot of times people are trying to solve this archive directly with the DAM, but I think there's a gap in between. And this is the tool, I think, that solves that, which is how do we go from those buckets of chaos into a final system? You kind of need something in the middle to curate it properly, to orchestrate it, to layer on that intelligence. And
yeah,
really excited.
And so we've had a lot of fun building this, but I think we're almost out of time. And I think, we do have time for questions. I'm not sure what the format's like, but we can take a few questions, I guess.
How long did it take to build? Using
To index it or to build the platform? To index.
Oh, to index, great question. Indexing was extremely quick. That was the amazing thing. Once we had the foundational systems in place, which we were building on the fly, once we had a new production, a new show, we could be up and running that same day. And so what's great is within, literally we brought onboarded animation from the Monday. They said, this is amazing. We had them up and running on the Friday, and now they had a whole new interface to all their data that they'd never had before. And they're at the tail end of Cat in the Hat, and they're like, holy crap, like we can now see everything and find everything. And it started, unlocking new opportunities for licensing and marketing downstream. So extremely lightweight to implement, and yeah, extremely efficient. You Mike?
No, but thanks. What were the most inference-heavy or compute-heavy workloads as part of this process, and how does that continue into the future now that the indexing has been done?
So interestingly enough, indexing the storage itself, StorageDNA. I don't know if you want to talk to that first.
I mean, to us, we like to get deployed as close to where the content is. So in this case, I think, did we use any cloud CPUs for this, for the indexing, or was it all on-prem?
No.
Yeah, so it was just on-prem CPUs. But, the indexing is IOPS heavy as well. But, once we're done with it, then it's, onto the engines that you've built.
Yeah, and for us, there's a little bit of a model that does the enrichment. So there's a little bit of weight there. So one instance runs a GPU for that. Thumbnailing on the fly, it has its own GPU instance to do that efficiently. And then as we're going through, then the transcoders, which will spin up and spin down. So if I see a set of EXR frames or TPXs, I'm going to spin up in 25 seconds, process, 300 frames in about 60 seconds, and then spin back down in 10 seconds. So all of that, is super tight. Same with the 3D models. So there's a bit of weight in converting those, and then it goes into the dam, and the dam will have its own sort of proxy creation pipeline, and then it'll back up to Glacier, and we have a sort of a whole tiered layer there. Thank you, everybody.
Well, one of the things I want to add on is designing pipelines like this is very hard to do with on-prem infrastructure, right? We do rely on the fact that you have infinite capacity, infinite RAM, infinite memory, but you don't have to use all of it, right? You can spin stuff up and spin it down, and if you've built an infrastructure that can do it efficiently, well, that's the sort of way to go now, right? So.
What did you do with the dedupes? Did it flag? Were you looking at like specific time? I'm sorry, with your dedupes, how were you flagging them, and what were you doing after you found them? Did it merge or?
There's a few different ways. So literally, as you're navigating the files, it'll literally in the file list tell you this has 17 duplications, this has 19 duplications. You click on it, it'll tell you exactly where they all are. And I started building this pipeline of like, oh, maybe I'll choose which one I want to keep, and then it will help me ignore the rest, and I can go turn off this ignore pipeline. And then it evolved from there to going like, if I choose that's the file I want to ingest, I can filter and say, hide all of the files I've chosen to ingest as well as its duplicates. And by doing that, it meant I didn't have to worry about those. I was kind of choosing like, that's the hero one of the 17, or at least that's the one I'm choosing to put effort in to push into the system. And this is how I want to catalog it. So all those other duplicates that are structured, all these other places aren't as relevant to me. But what I'm doing now is using the file paths and the file names of those other files to also inform the first one, because there may be other information in there that's useful. Thank you. It's pretty cool. Cool. Thank you, everybody.
Thank you so much.
Have a great show.